Okay, so this video we're going to review balancing equations and work a few more examples. So I want you to write each one of these down in your notebook. So you might have to pause the video or, if you need me to slow down. So this first equation says that HgOH2, that is mercury oxide, or hydroxide, mercury 2 hydroxide plus H3PO4 is phosphoric acid. And that's your reactants. And then the arrow means to produce. So they produce Hg3PO42, which is mercury 2 phosphate, plus H2O, which is water. So this reaction, first of all, we have two reactants, two products, and they're all compounds made up of more than one type of element. So that means that this is a double replacement reaction. Now we have to balance this reaction according to the law of conservation of mass, because atoms are not created or stored in reaction, the atoms are conserved. So I gotta have the same number of atoms of each element in my reactants and my product. So to balance it, I need to write down every element that makes up this reaction. Now remember, if I have polyatomic ions, I can leave them in ion form. However, problem with this, I don't want to leave OH and like PO4 because I have oxygen in both of those ions. So it's going to be easier for me to split that apart into the individual atoms instead of trying to mess with the ions in this case. You're just going to have to look at it and make a determination. So this is made of Hg. It's made up of oxygen, hydrogen, and phosphorus. Those are the four elements in this reaction. So now I look, I got one mercury. Now oxygens I have, look in this first part, I got 1 times 2, 2 there, plus, and I got 4 more for a total of 6. Hydrogens I have 1 times 2, 2 there, plus, and I got 3 more for a total of 5. And then phosphorus I have 1. On the right I have 3 mercuries. Oxygens I have 4 times 2 is 8, plus this 1 more gives me 9. Hydrogens I have 2. Phosphorus I have just 1. Well, 1 times 2 gives me 2 of those. So I'm going to start off balancing my mercuries. They're the easiest. I got 3 on the right, I need 3 on the left. I'm going to put a 3 right here. It's going to give me 3 mercuries. It's going to change my oxygens and hydrogens. Now I have 1 times 2 oxygens times 3 gives me 6. 6 plus 4 more gives me a total of 10. Hydrogens, I have 1 times 2 is 2. 2 times 3 is 6. 6 plus this 3 here gives me a total of 9. So this is one of the hardest reactions to balance. If you can do this, you should be able to do any of them. So now when I look at this, next easiest would be my phosphorus is 2 to 1. So I got 2 on the right and 2 on the left. I have to put a 2 right here. It's going to change my phosphorus to 2, which balances those, but it's going to change my hydrogens and oxygens. I go back to the beginning now. Oxygens, I got 1 times 2 is 2. 2 times 3 is 6. Plus, now I got this 2 times 4 would be 8. So 6 plus 8 gives me a total of 14. And hydrogens is going to be, if you look at this first compound, 1 times 2 is 2. 2 times is 3 gives me 6. 6 plus this 2 times 3 here gives me 6 hydrogens total. So that's a total of 12. Oh, so I go look. The only thing I can balance, I got oxygens 14 to 9. I can't do that. Hydrogens 12 and 2. So I need 12 on the right. I have to put a 6 right here. That gives me 12 hydrogens. Balances those, but let's see what it does to my oxygens. I got 4 times 2, 8, plus the 6 times 1. 8 plus 6 is 14. That balances my oxygens out. So that's a balanced equation. So on the simplest level, This reaction, 3 molecules of HgOH2 react with 2 molecules of H3PO4 to produce 1 molecule of Hg3PO42 plus 6 molecules of H2O. That's the ratios of the molecules and how they react in the products, the numbers of the molecules on the simplest level. Okay, next example, write this one down. Have magnesium carbonate, MgCl3, plus aluminum chloride, AlCl3, produces magnesium chloride, MgCl2, plus aluminum carbonate, Al2CO3, 3. So this reaction, first of all, has 2 compounds, as a compound plus a compound, producing a compound plus a compound, so this is a double replacement. Now, when I start to balance this, I draw my line, and I want to put all the elements that make this up. And I have magnesium. Then if I look, I got magnesium bonded with 2 elements of CO3 is a polyatomic ion. And it appears the same on each side. I have carbon and CO3 and it's CO3 on the other side. So instead of splitting it up into carbon and oxygen separately, which I could, there's nothing wrong with that. I can also leave it in ion form if I want to, and I can, do the ions instead of the individual elements. This will save me some time, but there's nothing wrong in breaking up into carbon and hydrogen. And this is also of aluminum and chlorine. So on the left I got 1 magnesium and I got 1 carbonate ion. And on the left I got 1 aluminum and 3 chlorines. On the right I have 1 magnesium, I have 3 carbonate ions. There's 3 on the outside. The parentheses tells me I have 3 of these. Al I have 2, chlorines I have 2. So I start to balance this. I can pick my aluminums first. And I need to go put a 2 in front of here as a coefficient. I cannot add it in the middle anywhere. I got to add it at the front. That means my aluminums now are 2. But then I have 2 times 3, 6 chlorines. Then I'll look next. What can I balance? My chlorines. So when I go to balance my chlorines, I will need to put a I got 6 there. I need to put a 3 right here. That will balance my chlorines, make me have 6. Magnesiums, though, it changes those to 3. So then I go to balance my magnesiums. I go and put a 3 right here. It means I'm going to have 3 magnesiums. It's going to change my carbonates now to 3 times 1. It's for a total of 3 of those, and it balances those out. Like I said, I could have split this up into carbon and oxygen separately. Nothing wrong with that. It just took me a little bit longer. So this reaction happens on the basic level, simplest level. 3 molecules of MgCl3 react with 2 molecules of AlCl3, and the products of those reactions, once this metal reacts with this non-metal, and then this metal aluminum reacts with carbonate, it's a double replacement. It's 3 molecules of MgCl2 and 1 molecule of Al2CO3. Next example. We have H2SO4 plus PbOH with a 4 on the outside. That's lead 4 hydroxide. And the products are lead 2 sulfate, that's PbSO4 plus H2O. So I look, I have a compound plus a compound producing a compound plus a compound. This is double replacement. Now next I have the elements to make this up. Since I have SO4 and I have OH, OH doesn't look the same on the other side. It's not. It's H2O and OH. So I really need to split the oxygen and hydrogen separately. And since I have SO4, the polyatomic ion appears the same. I could leave it at SO4, but it'd be easier since I have oxygen in both of those ions just to split it up into the individual elements. So this is made up of hydrogen, sulfur, oxygen, lead, those four elements. So on the left I have 2 hydrogens. Actually I have 6. I got 2 here plus and I got 1 on this side times 4 gives me a total of 6. Sulfurs I have 1, oxygen I have 4 plus, and then it's 1 times 4 gives me 4 more for a total of 8. Lead I have 1. On the right I have 2 hydrogens. I got 1 sulfur on the inside times 2 on the outside gives me a total of 2. Oxygens I have 4 times 2 is 8 plus this 1 more give me 9. And then PB I have 1 of those. Now I'm going to balance these first. Before I balance, I'm going to balance my sulfurs first because it's a 1 to 2 thing. I think those would be easiest. So when I do that, I will need to put a 2 in front of here to make me have 2 sulfurs. But it's going to change my hydrogens and oxygens. Now I got 4 hydrogens, 2 times 2 is 4, plus these 4 more over here for a total of 8. I have oxygens. I have 2 times 4 is 8 plus 4 more right here would be 12. Now I go over and balance my hydrogens on the right side. I got 8 and 2. If I put a 4 here, it's going to make me have 8 hydrogens. It's going to change my oxygens. Now I got these 4 times 2 is 8 plus, these 4 more oxygens. That gives me 12, and that balances it out. So it really wasn't hard to balance once I got started, but you have to be very careful about your oxygens or separating your reactants, about counting those, especially when you add coefficients. So the way this reaction would happen in nature, or in the simplest form, 2 molecules of H2SO4 would react with 1 molecule of PbOH4 to produce 1 molecule of PbSO42 plus 4 molecules of H2O. Now, next example, you rewrite this one down. In this example, C3H6 reacts with oxygen gas, that's O2, it's diatomic, to produce CO2 and H2O. And we had talked about this type of reaction. If you have a hydrocarbon reacting with oxygen gas, products are CO2 and water, it's always a combustion reaction. Now to balance these, sometimes they can be tricky, so there's a trick to that. This is made up of carbon, hydrogen, and oxygen. On the left, well, I have that on each side. On the left, I have 3 carbons, I have 6 hydrogens, and I have 2 oxygens. On the right, I have 1 carbon, 2 hydrogens, and I have 2 oxygens here, then 1 more gives me a total of 3. So when I balance these, I always want to start with my carbons, so that's the easiest. If I got 3 on the left, I need 3 on the right. I have to put a 3 right here. That's going to give me 3 carbons, and then it's going to change my oxygens to 3 times 2 is 6, plus 1 more gives me a total of 7. And then I look at my hydrogens. My hydrogens, I got 3 on the left, I need 3 on the right, so I need to put a 3 right here. So that's going to give me That's going to change my hydrogens to 6. Going to balance those. But oxygens is going to change to 3 times 2 is 6. Plus this 3 times 1. There's 3 more of them there. So that's going to give me a total of 9. So now, how do I balance this? I got an odd number. I got 9 on the right oxygens. I got 2 on the left. I could mess around with numbers a long time and figure out how to do this, but the easiest way, what times 2 equals 9? If I divide 9 by 2, that'll give me 4.5, so 4.5 times 2 equals 9. So if I put 4.5 here, that would balance it out. 4.5 times 2 equals 9. It's balanced. The problem is I cannot have half of a molecule. I can't have 4.5 molecules. But this coefficient, to get it to a whole number, I can just double each of these coefficients. I can multiply each of them by 2, and look what happens. If I have 2 times 1 gives me 2 C3H8 plus 4.5 times 2 is 9. That's 9 O2 produces 3 times 2 is 6. That's 6 CO2. 6 CO2 plus, and then 3 times 2 is 6 H2O. So what happened is, I come and when I balance this to make it have oxygens have 9 on the left, I had to put a 4.5 in there. I can't leave it as a decimal though. I can only double it to make it a whole number, but I have to double every coefficient. That's why I ended up with these numbers, because I doubled it. So this reaction in its simplest form, molecular form, 2 molecules of C3H8 reacts with 9 molecules of O2, and it produces 6 molecules of CO2 and 6 molecules of H2O. Now this is important because in the next unit we'll use these numbers to figure out, if I start with 100 grams of oxygen, how much carbon dioxide will be produced. I'll be using these numbers to help me solve that problem. And if we look at one more example, just like this. If we have another combustion reaction, because I have a hydrocarbon, something made of carbon and hydrogen reacting with oxygen gas as a reactant to produce always carbon dioxide and H2O, it's always a combustion reaction. Now I just need to balance it if it needs balanced. So in this case, carbon I have 8 on the left, hydrogens I have 18, and then oxygens I have 2. On the right I have 1 carbon, I have 2 hydrogens, and I have 2 oxygens right here plus 1 more gives me a total of 3. So I'll start to balance this. I'm going to start with my carbons. I need to put a number in front of CO2 to balance that. And I put an 8 there. 8 times C gives me 8 carbons, but it changed my oxygens to 8 times 2 is 16 plus 1 more gives me a total of 17 oxygens. Now look at my hydrogens. 18 on the left, I got 2 on the right. I need to put a 9 in front of here. That would give me 18 hydrogens, but it's going to change my oxygens. Notice now I got 8 times 2 is 16 plus 9 more. It's 9 times 1 is 9. 16 plus 9 would give me 25. Now I got 25 oxygens on the right. I need 25 on the left. What number can I put right here to equal 25? What times 2 equals 25? If I just took 25 divided by 2, give me 12.5. But if I notice, and that gives, that balances my oxygens, but if I notice, I can't have 12.5 molecules. I need a whole number. So what I need to do is double each one of these coefficients. So when I rewrite this, it would be 1, that's a 1 there. 1 times 2 is 2. C3H18 plus 12.5 times 2 is 25 plus 25O2 produces 8 times 2 is 16, so it's 16 CO2 plus, and then 9 times 2 is 18 H2O. So this reaction, the simplest form, happens in these ratios. 2 molecules of C3H18 reacts with 25 molecules of O2 to produce 16 molecules of carbon dioxide plus CO2 plus 18 molecules of H2O.